fly in the sky. I can go twice as high. Take a look, it's in a book, a reading rainbow. I can go anywhere. Friends to know and ways to grow, a reading rainbow. I can be anything. Take a look, it's in a book, a reading rainbow. A reading rainbow. A reading rainbow.
Hi everyone, how's it going? Welcome to another awesome REL Reads Rainbows. I am your host, the one, the only REL, and today we are going to be starting or picking up our... That looks odd. We're going to be doing chapters 3 and 4 of Kings Dethroned. How do you know all this stuff? Because I read books. Thank you. Exactly. What up, Austin? Thank you for being here. Much love. Was it the stream with ODD, the 3cast? Is that what it called? What did it call it? With ODD and Dave and Hippo Productions. That was awesome. I was listening to them while I was getting ready and while I was working out and stuff. And I just love that conversation. That's going to be an awesome stream. So you guys should go check out ODD TV and because they're going to have an awesome stream. I think they're going to have it every Tuesday right before this stream. So you can go there and then you can come here to read some books, because that's how we know stuff, because we read. So today we have some diagrams in these chapters, and I thought ahead and went ahead and I tried to take some pictures. So I'm going to try to put them up. But let me go ahead and put the first picture up while I'm actually thinking about it, because, oh gosh, there's so many. Oh, that's right. All of them have to actually be open, which is weird. Hey, Pepper, welcome. Wrench you up. Oh, I'm on StreamYard. Hold on. How do I do this? I wasn't even time toggle participants. See, look, awesome. Oh, there's 3 dots. Word. Is that, did I do it? Did it happen? Oops. Yay! Oh gosh, I figured it out. Thank you for that reminder. I'll have to remember to keep doing that for everybody. Okay, so what was I doing before? Oh, thank you, Austin. I appreciate you. Hey, Jonathan. Gosh. Anyway, I can't. You guys are rolling in. I appreciate you. There's Law. Hey, Law. Okay, I have to figure out what I was doing again. Is this the picture I want? Yes, this is the picture I want. Okay. So for now, we're going to put it that way. And I'll make it bigger a little later on. So I hope you guys had a great day. I am excited to find out more about how history, or how science, really, how the science of astrology and astronomy was built based on a single assumption or a single statement, whimsical statement that was not based on factual input or knowledge whatsoever. So let's figure out how our entire science and solar system theology is fabricated. Let's find out, right? Let's find out. Oh gosh. Okay. So we're gonna go ahead and get started with chapter 3. It's called Old Romer's Blunder. Oh, and I forgot to say that if you guys want to read along, you can go to the description. There are 2 different links to PDF type forms of King's Dethroned for you to read along. Chapter 3 is on page 10 of the actual book. I'm not sure what page it would be on in the PDF form, but if that is, if you decide to read along, that is where you'll find it. So thank you again, Austin and Jonathan and Law and Pepper. Oh, I gotta remember because Law is here. Hey, I learned how to do something. Yeah. Look. Yeah, man. Now we got it. Oh, somebody else. We got somebody else. Turbo, you in the house? In his house? Welcome. I appreciate you guys. All right, so let me go ahead before I get more sidetracked by talking to you. I will not actually read the book. Okay. So chapter 3 on page 10, Old Romer's Blunder. Among the many ambitious spirits of that time was one whose name is known only to a comparative few. Nevertheless, he has had a considerable influence both on astronomy and physics. Old Romer, best remembered for his observations of the eclipses of Jupiter's satellites. The eclipses of Jupiter's satellites. I feel like that's something I should look up and find the pictures of. A study of the records which have been made during more than 3,000 years shows that eclipses repeat themselves with clockwork regularity. Eclipses repeat themselves with clockwork regularity, so that a given number of years, months, days, and minutes elapse between every 2 eclipses of a given kind. But old Romer observed that in the case of the eclipses of the satellites or moons of Jupiter, the period of time between them was not always the same, for they occurred 16.5 minutes later on some occasions than on others. So this guy was clocking the This guy was clocking the eclipses, and he found out that they were 6.5 minutes later on some occasions than others. Like, you've got to be super into your science to be clocking, and that's what we need to be doing. I mean, I'm just saying, I understand the precision that has to go into this, right? So he found out 16.5 minutes later on some occasions than others. He therefore tried to account for this slight difference in time and was led to some strange conclusions. Okay, so this is where the diagram comes in. So let me go ahead and make it bigger. I don't know. Can I make it really, really big? Can you guys see that? I don't think I can make it any bigger than that because I'm just screen sharing. Or maybe I could do that. Oh, that takes away things for me. How do I exit? I didn't like that. Y'all can zoom in if you need to. Okay. So this is diagram 3. The eclipses occur at different seasons of the year so that sometimes they can be seen within the Earth at A, seen in diagram 3, and at other times when the Earth is at B, on the opposite side of the sun and the orbit, according to Copernican astronomy. So old Romer reflected that when the observer is at B, over here, I don't think you can see my mouse. When the observer is at B, he is further from Jupiter than he is when the Earth is at A, but by a distance as great as the diameter of the orbit. So he reflected that the observer at B is further from Jupiter than when he what? Hold on. So old Roma reflected that when the observer is at B, he is further from Jupiter than he is when the Earth is at A. That that fucked me up because I was like, why are you jumping around from who he is? By a distance as great as the diameter of the orbit. So by the distance as great as the diameter of the orbit. Okay, looking at that, I see that. That gave him a new idea and a possible explanation. So because it's further away on the other side, it gave him a new explanation. He thought that although light appeared to be for an ordinary purpose instantaneous, it really must take an appreciable time. Appreciable? It really must take an appreciable time to travel over the immense distance from Jupiter to the Earth, just as a ship takes so long to travel a given distance at so many miles per hour. In that case, the light from Jupiter's satellites would take less time to reach the observer when the Earth is at A than it would require to reach him at B, on the further side of the orbit. And as a result of these reflections, he reached the conclusion that the 16.5-minute difference in time has to be accounted for in that way. So he's saying that because the eclipses of Jupiter's satellites are 16.5 minutes in difference, because on one side of the sun, the Earth is further away than on the other side. That is interesting. Following up this idea, he decided that if it took 16.5 minutes longer for light to travel the increased distance from one side of the orbit to the other, it would require only half the time to travel half that distance, so that it would travel as far as from the sun to the Earth in 8.25 minutes. Therefore, he gave it as his opinion that the distance to the sun was so tremendous that light, quote unquote, light traveling with almost lightning rapidity took 8.25 minutes to cover the distance. This ingenious hypothesis applied strongly to the imagination of contemporary astronomers, so that they allowed it to pass without a sufficient examination, with the result that eventually it took its pace. Let me just start. So that they allowed it to pass without any sufficient examination, with the result that eventually it took its place among the many strange and ill-considered theories of astronomy. However, we ourselves will now do what should have been done in the days of old Romer. We will stand beside him, as it were, and study these eclipses of Jupiter's satellites, just as he did, from the same viewpoint of Copernican astronomy. And then we will find whether his deductions were justified or not. How's everybody doing? Is everybody still with me? Y'all still following? I think I can take this down now. We can go back to doing that. The eclipses are to be seen on one occasion when the observer, or Earth, is at A. Oh, it's still there, at A. All right, bet, Jonathan. Jonathan says he's listening. Oh, look, I remember I can do this too. What? Jonathan says he's listening. And Law said he's going to be right back. Okay, so the eclipses are to be seen on one occasion when the observer or Earth is at A, and on another occasion when the observer or Earth is at B. While the light of Jupiter's satellites, or the image of the eclipse, is supposed to cross the orbit at one observation but not the other. Wait, that didn't make sense. Oh, what's up, El Cole? I see you. I see you. Okay, the eclipses are to be seen on one occasion when the observer is at A, or on another occasion when the observer is at B, while the light of Jupiter's satellites is supposed to cross the orbit at one observation but not at the other. The image of the eclipse. It is important to note that the observer at B will have to look in a direction towards the sun and across the orbit, while the observer at A will see the eclipse outward from the orbit. I said the absorber, like they were absorbing something. All right, we've got a new picture coming up here. Let me close that out and let me find the next picture. Make this big for you guys. Okay. It is important to note that the observer at B will have to look in a direction toward the sun and across the orbit, while the observer at A will see the eclipse outward from the orbit in a direction opposite the sun. Old Romer found that the observer at B saw the eclipse 16 and a half minutes later than he would have seen it from A, and he believed that this was because the image of the eclipse had a greater distance to come to meet his eye. Let us now consider diagram 4, which shows two observers in the positions Old Romer supposed. Diagram 4 is now displayed for you on the screen. I thought that was the end of the sentence, but it wasn't. So let us consider diagram 4, which shows two observers in the position Old Romer supposed the Earth to occupy at the respective observations. Okay, so these are the people at their respective observations observing Earth. And I'm looking at this diagram, and I believe the big circle at the bottom is the Earth, because it says orbit of the Earth, and it has the sun there. Oh yeah, we're A and B, observer A and observer B, and the sun, and that's the orbit, and this is Jupiter up here. All right, I'm following. We find that A would see the satellite in a state of eclipse, while it would be hidden from B by the planet Jupiter. Triangle A to Jupiter and then to B. Okay. Oh, no. Triangle A and then 1 to B. So A would see the satellite in a state of eclipse, while it would be hidden from B by the planet Jupiter. The planet and its satellite are both moving around the sun toward the east, as shown by the arrows, but the satellite is like a moon traveling around Jupiter, so that it moves faster than the planet. The satellite is eclipsed by Jupiter only when the two are together on the same line, like the sun, the dotted lines. Okay, so when the two are on the same dotted lines, they're together. But as time passes, the satellite moves to the eastward of that line. It passes Jupiter, and then it can be seen by the observer at B, which is triangle B2A. Thus, it is that B sees the eclipse a few minutes later than A, and that is the very simple explanation which Old Romer overlooked. It would be possible to write a volume on this subject, and there are some who would want to debate it at an interminable length. But in the end, the explanation would prove to be just this, which I prefer to leave in its simplicity. The 16.5-minute difference in time is due to a difference in the angles from which the eclipses are seen, and is not in any way connected with distance. And so the speculations of Old Romer concerning the velocity So the speculations of old Rome were concerning the velocity of light and the probable distance of the sun amount to nothing. That's the end of chapter 3. Chapter 3 was all about debunking or re-establishing why there's a 16.5-minute difference with seeing Jupiter's satellites from different angles on Earth. And that was pretty. What do y'all think about that? Let me bring myself back on in here. What do y'all think about that? I don't feel like I have ever heard, I can't remember as a time where there was an eclipse and someone told me it was because Jupiter or its satellites were eclipsing. I feel like the only eclipses that I really remember seeing or being iconic for me are like the sun and moon. You know, the biggest ones. You have you guys seen that that one video up close? I think it was Instagram. Have you guys ever seen Instagram? They're on Facebook and Instagram, and I think they need to get a Telegram too, because they'd be awesome. They post real life pictures of stars and stuff, and they had they were in a plane and super zoomed in with like a P9000 like P9000 camera, and you could see like up close like the gases like coming up off of it or something, and it was just in the line of the moon and the sun. They were the exact same size. That was so cool to me. Okay, so any questions from my class? I don't think so. It looks like everyone's still doing good. All right, so that was the end of chapter 3. We're gonna move on to chapter 4. Whoop whoop. We're moving through. We're not taking up too much time, not stopping too much, but I am trying to learn. And you know, apparently this old English is tripping me up because I stopped talking like that. Oh, Cole, you said you never saw that? Yeah, no, I need to find that. I can send it to you, definitely. It is awesome. They were in a plane, and when they zoomed into like the gases on the sun, it was like pink. Like, I guess the chemical reaction of like the sun and moon coming into contact with each other in some way, shape, or form. It was just pretty cool. It was pretty cool. All right, so we're going to chapter 4. Chapter 4 is entitled Giants of Modern Astronomy. And we don't need this anymore, so let me get this out of the way. All right, chapter 4. Before passing on to the more important part of this work, it is only just to record the fact that the first practical work of triangulation since the time of Hippocrates was performed by Jean Paccard and J. and D. Cassini between Paris and Dunkirk toward the end of the 17th century, when Newton was working for his theories. Important part is the first practical work in triangulation since the time it was performed by Jean Paccard between Paris and when Newton was working on his theories. At this time, the Copernican theory of astronomy was well established and was accepted by all the scientific world, though it is probable that the public in general found it difficult to reconcile the idea of an Earth careering through space. Careering. It's been a minute since I've seen the word used that way. At the time, the Copernican theory of astronomy was well established and was accepted by all the scientific world, though it is probable that the public in general found it difficult to reconcile the idea of an Earth careering through space at prodigious speed within the common sense and reason. Even the most ardent followers of Copernicus and Galileo recognized this difficulty, and some strove to find a satisfactory explanation. Nearly 100 years ago, Kepler had suggested that some kind of unknown force must hold the Earth and the heavenly bodies in their places. And now, Sir Isaac Newton, the greatest mathematician of his age, took up the idea and built the law of gravitation. The name was derived from the Latin word gravus, which means heavy, having weight, while the law of gravitation is defined as that mutual action between masses of matter by virtue of which every such mass tends toward every other with a force varying directly as the product of the masses and inversely as the square of their distances apart. What? That's supposed to be? That's the definition of gravity. That was 1, 2, 3, 4, 5, 6, 7. That was 6 lines of explanation. And I don't feel like I understood it better at the end of the explanation. Whatever. Okay, so the word gravus means heavy or having weight, but they give a 6-line explanation of what gravity actually means. Reduced to simplicity, gravitation is said to be that which attracts everything toward every other thing. That does not tell us much, and yet the little it does tell us is not true. For a thoughtful observer knows very well that everything is not attracted towards every other thing. The definition implies that it is a force, but it does not say so, for that phrase, mutual action, is ambiguous and not at all convincing. Amen, amen. The Encyclopedia Britannica tells us that the law of gravitation is unique among the laws of nature, not only for this wide generality, while the Encyclopedia Britannica tells us that the law of gravitation is unique among the laws of nature, not only for its wide generality, taking the whole universe into its scope, but in the fact that, so far as yet known, it is absolutely unmodified by any condition or cause whatever. Here again, we observe that the nature of gravitation is not really defined at all. We are told that masses of matter tend towards each other, but no reason is given why they would do so or should do so. While to say that it is absolutely unmodified by any condition or cause whatever, it is one of the most unscientific statements it is possible to make. There is not anything or force in the universe that is absolute. No thing that goes its own way and does what it will without regard for other forces or things. The thing is impossible, and it is not true. Therefore, it has fallen to me to show where the inconsistencies in it lie. So, to sum it up so far, he is saying that basically gravitation is impossible and not true because nothing in the world, in our realm, in this universe, goes its own way without having to take regard for other forces or other things. Every single thing that, I definitely believe this is true, that every single thing that that we come in contact with, or like living beings, when they come in contact with each other, even inanimate objects, anything that is part of nature, rocks, crystals and plants and animals, anything like that, we're all giving off energy and exchanging energy with each other and shifting each other in some way, whatever we're doing. So anything that you observe, you are interacting with, and it is interacting with you on a very, very spiritual, not even just spiritual, because I think it's more than spiritual. It's a physical, it's an actual, it's energy, exchanging. There is ways for us to actually exchange energy with with everything around us all the time, and we can understand that and be aware of it on a given basis if we were taught how to, if we were more in tune with ourselves as human beings, as the Creator intended us to be, and if we were more in tune with our surroundings, our nature, as our Creator intended us to be. So, I mean, this is, just hitting home for right now. So I'm ready for the brother to come with and show the inconsistencies and the lies. The name given to this mutual action, hold on, I've been reading for a minute. Let me grab some tea here. I put a little sleepy time in my tea to make sure that I could go a little sleepy sleep. Oh my gosh! Let me not get sidetracked, because Lord knows I will. I'm here to do something. But guess what, you guys? I got my grounding mats today, or yesterday. Whew, I needed that. Super excited to finally use them and sleep on them. I don't think I'll be able to use it at my desk during the day like I wanted to, because one side of the apartment is not grounded. Whatever. But I can use it in my room, and I think that's even more important when I sleep, to be grounded. So wait to see a update or a review on that in coming weeks, because I'm definitely going to be talking about that. I got another book. There's so many books I want to read. Oh my gosh, there's so many books I want to read. All right, okay. We're talking about gravity again. I know I'm getting sidetracked, but that's okay. The name given to this mutual action means weight. And weight is one of the attributes of all matter. Merely to say that anything is matter or material, anything that is matter or material implies that it has weight, while to speak of weight implies matter. Matter and weight are inseparable. They are not laws, but fundamental facts. They exist. I like that it's about facts. Weight and matter exist. But it has been suggested that gravitation is a force. Indeed, we often hear it referred to as the force of gravitation. But force is quite a different thing than weight. It is active energy expressed by certain conditions and combinations of matter. It acts. All experience and observation goes to prove that material things fall to earth because they possess the attribute of weight, and that an object remains suspended in air or space only so long as its weight is overcome by a force which is contrary. And while we realize these simple facts, we see that gravitation in reality And when we realize these simple facts, we see that gravitation is in reality conditioned and modified by every other active force, both great and small. Again, gravitation is spoken of as a pull, an agent of attraction that robs weight of its meaning, something that brings all terrestrial things down to earth, while at the same time it keeps the heavenly bodies in their places and prevents them falling towards each other or apart. The thing is altogether so wonderful, it is not natural, and the theory is scientifically unsound. Every man, however great his genius, must be limited by the conditions that surround him, and science in general has not sufficiently advanced 200 years ago. Every man, however great his genius, must be limited by the conditions that surround him, and science in general has not sufficiently advanced 200 years ago to be much help to Newton, so that for lack of information, which is ordinary knowledge to us living in the 20th century, he fell into the error that attributing the effects of weight and force to a common cause, which, for want of a better term, he called gravitation. But I have not the slightest doubt that if he were living now, he would have arrived at the following more reasonable conclusions: that terrestrial things fall to Earth by gravis, weight, because they are matter, while the heavenly bodies, which also are matter, do not fall because they are maintained in their courses by magnetic or electric force. Hey. Now that sounds much more plausible than whatever the attractions of masses to each other masses and be. Like, no. I think as complex as our creator is, because this place is complex down to the micro level, down to the micro level in our cells, like super detail oriented and all of that. He is also simplistic, like there's a simple answer for things, we don't have to try so hard. Are there mysteries that we're not in part given? Yes, definitely. But I don't think it has to be so overly complicated. I don't think he intended for that. We live in a clock. Our terrarium is a clock, or it might be a crystal. I was watching Awesome Austin and the Mellow Dome, and they were talking about how it could be a crystal, and I cannot wait to get to talk to Cammie one day so that she can just blow my mind with all this stuff and all of the knowledge she knows. And so, I'm sorry, I'm getting sidetracked again. We got a couple more pages to go in this chapter. I've got a couple more slides to show. So, just to sum up what I've said so far is that terrestrial things fall to Earth by gravis, which is weight, because they are matter, which weight and matter are two factual things that exist, while the heavenly bodies, which are also considered to be matter, don't fall because they are made by other things like magnetic or electrical force. Another figure of great prominence in the early part of the 18th century was Dr. Halley, who survived Sir Isaac Newton by some 15 years, and it is to him that we owe nearly all the methods of measuring distance which are used in astronomy at the present day. Okay, so Dr. Halley, we owe all the methods of measuring distance which are used in astronomy to the present day. So far, no one had seriously considered the possibility of measuring the distance to the sun, planets, or stars since Hipparchus had failed. Since no one had seriously considered the possibility of measuring the distance of the sun, stars, or planets since Hipparchus had failed, way back in the 2nd century BC, but now, since the science had made great strides, it occurred to Dr. Halley that it might be possible at least to find the distance from the Earth to the sun, or to the nearest planet. Remembering the time-honored dogma that the stars are infinitely distant, inspired by the magnificence of the Copernican conception of the universe, and influenced, no doubt, by the colossal suggestions of old Romer, he tried to invent some means of making a triangulation on a gigantic scale, which with a baseline of hitherto unknown dimensions. So he was inspired by the stars are infinitely distant, and other people who were also wrong. And he tried to invent a gigantic scale of triangulation with unknown dimensions. Long years ago, Kepler had worked out a theory of the distances of the planets with relation to each other, the principle of which was, when expressed in simple language and in round figures, is as follows. If we know the distance of any one of the planets, we could use that measurement as a basis for which to estimate the others. Thus, Venus is apparently about twice as far from the sun as Mercury, while the Earth is about 3 times and Mars 4 times as far from the sun as Mercury. So that should be the distance of the smallest planet, be, let's say, us, 50 million miles, when Venus would be 100, the Earth 150, and Mars 200 millions of miles. Millions of miles. We're not talking about thousands. We're not talking about 1,500 miles. We're talking about millions of miles away. This seems to be the simplest kind of arithmetic. But the whole of the theory of relative distance goes to pieces because Kepler had not the slightest idea of the linear distance from the Earth to anything in the firmament, and based all his calculations on time and on the apparent movements of the planets in Azimuth. I do not know what this word is. Pause for dictionary. Azimuth. Oh, okay. Let's screen share. Show y'all what I'm seeing. All right, so Azimuth. What's a good one? I liked this diagram here, and I hope this over here has it, but I just don't trust Wikipedia. An arc of the horizon measured between a fixed point, such as true north, and the vertical circle passing through the center of an object, usually in astronomy and navigation, clockwise from the north point through 360 degrees. Horizontal direction expressed as the regular distance between the direction of... Wait, am I sharing this for real? I am, but it's not big enough. Okay, let's try this. There we go. Okay. Is that better? Can you guys see? You following along? All right. A horizontal direction expressed as the angular direction between the direction. Horizontal direction expressed as the angular distance between the direction of a fixed point, such as the observer's heading, and the direction of the object. Illustration of azimuth. 1. 6 is, I guess 6 over here is azimuth. Okay, so this right here. Okay, so all right. Why did I need to know that word? Okay, so we know that the azimuth, I don't know, it just looks weird. Azimuth is the horizontal direction expressed as the angular distance between the direction of a fixed point. Angular. Okay. So he was saying why are these sentences so long? It's like I'm trying to go back to the beginning of the sentence and it's like a paragraph. By the time I read the whole dang paragraph, I'm going to forget what azimuth was. By the time I get to the dang word. Oh gosh. Oh, sorry. Okay. So This seems to be the simplest kind of arithmetic, but the whole of the theory of relative distance goes to pieces because Kepler had not the slightest idea of the linear distance from the Earth to anything in the firmament, and based all his calculations on time and on the apparent movements of the planets in azimuth, that is, to right to left of the observer and to the right to the left of the sun. Necessity compels me to state these facts in this plain and almost brutal fashion, but it is my sincere hope that no reader will suppose that I underestimate the genius or the worth of such men as Newton and Kepler, for it is probable that I appreciate and honor them more than do most of those who blindly worship them with less understanding. I only regret that they were too ready to accept Copernican astronomy as though it were axiom. Oh Lord. we got another word. Oh, way to go. Where's the word? Oh, I found it. It's still big. AXIOM. Let's find out. Oh, see, this did the last one have a little sound?
Axiom.
Wait, did the other one have a word sound? It did.
Azimuth.
Okay. And axiom.
Axiom
and azimuth. We're reading new words here, boys and girls. Everybody gather around. We're learning more words here. Okay, so wait, I heard the word, but I didn't read what the word was. Okay, axiom, a statement accepted as true as the basis for argument or interference. An established rule or principle of a self-evident truth. A maxium widely accepted in its intricate merit. Maxium. So many different words. A general truth, fundamental principle, or rule of conduct. A proverbial saying. Oh, I could use that word a lot. A general truth, fundamental principle, a rule of conduct. So weight and matter are both axioms because they are general truths, fundamental principles. Right? Yeah, they are facts. El Cole says she loves the word sounds thingy.
Maxim.
Okay. All right, so let me go back to where I was. What am I doing? A statement accepted as true as the basis for argument or interference or Why my brain is, oh my gosh, my inference. Thank you. Argument or inference. I kept putting a T in there and I was like, no, brain, that is not. I always add letters or I subtract letters. My letters get all jumbled up and stuff. That is why anyway, I'm reading out loud. Aren't y'all proud of me? I'm overcoming all of my learning disabilities over here. Word. All right. Let's go back this way. So, necessity compels me to state these facts in this plain and almost brutal fashion, but it is my sincere hope that no reader will suppose that I underestimate the genius of the worth of such men as Newton and Kepler, for it is probable that I appreciate and honor them more than do most of those who blindly worship them with less understanding. I only regret that they were too ready to accept Copernican astronomy as though it were axiom and did not put it into proof. And that as a consequence, their fine intelligence and industry should have been devoted to the glorification of a blunder. So they said they were so smart, and it was so cool, their theory. They should have just been like, oh man, that was a really cool idea. It was just a blunder, but he's so smart. He was bound to figure out the right answer, right? Kepler's work was of that high order which only one man in a million could do. Kepler's work was of that high order which only one man in a million could do, but nonetheless his calculations of the relative distances of the planets depends entirely upon the question whether they revolve around the sun or not, and that we shall discover in due course. We shall discover that in due course. Hey, what up, Tully? What up? Good to see you, brother. Thank you for stopping by. Much appreciated. Much appreciated. However, Dr. Halley had these theories in mind when he proposed to measure the distance to Mars at a time when the planet reached its nearest point to Earth and opposite to the sun, and then to multiply that distance by 3, approximate, and in that manner estimate the distance of the sun. Oh, hey, Andrew. Thanks for stopping by. Appreciate it. He said he got all caught up. Did you watch on double speed? Okay, so Dr. Halley proposed to measure the distance to Mars at a time when the planet reached its nearest point to Earth, and then to multiply that distance by the approximate number of 3, and in that manner estimate the distance to the sun. He proceeded then to invent what is known now as the Dural method of measurement by parallax, which he described in detail in the form of a lecture to contemporary astronomers, introducing it by remarking that he would probably not be living when next Mars came into the required position, but others might at that time be the method but others at that time might put the method into practice. Yep, watched on double speed. I got you, Andrew. That's the way you gotta watch videos nowadays, because there's way too many videos out there and they're all super long, and you can't, you just can't time is precious, right? That's why I'm trying not to take too long. I'm sorry. Let me go ahead and get the next thing up. All right, so I can stop sharing that tab. I got the next picture. I got the next picture to share, the next diagram for the book. Yeah, look at there. All right, I think I'll be okay if let's make that bigger. And I'll be okay if I make this bigger for a second. He began by saying that if it were possible to place 2 observers at points diametrically opposite to each other on the surface of the Earth, as A and B in diagram 5, both observers looking along their respective horizons would see Mars at the same time, the planet being between them to the east of one observer and to the westward of the other. In these circumstances, the diameter of the Earth might be used as a baseline. The observers at A and B might take simultaneous observations, and the 2 angles obtained on being referred to the baseline would give the distance of the planet. But this was in the region of George II, long before the invention of steamships, cables, or telegraphs. And Dr. Halley knew that it was practically impossible to have B taking observations in the middle of the Pacific Ocean. No, excuse me. So he proposed to overcome the difficulty by the following expedient. Expedient. All right. What's the following expedient? He suggested that both the observations could be taken by a single observer using the same observatory. Thus, let an observer at A take the first observation in the evening when Mars will be to his east. Let him then wait 12 hours, during which time the rotation of the Earth while the rotation of the Earth will have carried him around to B, he may then take his second observation, Mars being at this time to his west, and the two angles thus obtained on being referred to on the baseline will give the distance of the planet. This proposition is so plausible that it has apparently deceived every astronomer from that day to this, and it might even now deceive the reader himself, were it not that he knows I have some good reason for describing it here. It is marvelously suspicious. It does not seem to call on our examination, or it does not seem to call for our examination, and yet it is all wrong. And Dr. Handley has a world of facts against him. No, exactly. That's assuming we are rotating, though. That's assuming we are rotating. So that's what Dr. Handley was saying, that the world was if the world was rotating. But as what is this guy's name again? Gerrard. As Gerrard said, it is marvelously suspicious. It does not seem to call for explanation or examination, and it's all wrong because Dr. Handley has a world of actual facts against him. He is at fault in his premises, for if the planet was visible to one of the observers, it must be above his horizon, and therefore could not be seen at the same time by the other, since it could not be above his horizon also, as in diagram 6. I mean 5. The one that's on right now, diagram 5. So he's at fault with his premise. For if the planet was visible to one of the observers, it must be above his horizon, and therefore could not be seen at the same time by the other, since it could not be above his horizon also. Yeah. Again, his premises are in conflict with Euclid. Euclid, because you say Eugene, like with a U, so Euclid, whoever Euclid is, his premises are in conflict with Euclid because he supposes Mars to be midway between A and B. That is between the two horizons, which are parallel lines, 8,000 miles apart throughout their entire length. And so it is obvious that if the planet, much smaller than the Earth, was really at that position, it could not be seen by either of the observers. The alternative, which Dr. Handley supposes, is as fallacious as his premises, for he overlooks the fact that according to Copernican astronomy, during the 12 hours which the Earth has been rotating on its axis, it has also traveled an immense distance in its orbit around the sun. All right, here's another diagram. Let's go. So wait, let's see, which one is better? I tried to get a couple of close-ups. I can't tell the difference. I think that one, so let's do this one. All right, let's rotate this here. Go the other way. Okay. And let's make it bigger over here. And then Let me make it, oops, full screen for a second because this one is big. Okay. So here is the diagram, which is actually diagram 6. So let me read this long ass sentence again. The alternative which Dr. Halley proposes is as fallacious as his premises, for he overlooks the fact that according to the Copernican astronomy, during the 12 hours while the Earth has been rotating on its axis, it has also traveled an immense distance in its orbit around the sun. The results are, number 1, that an observer starting from A can never arrive at B, but must arrive in 12 hours' time at a point somewhere around or about 3/4 of a million miles beyond it. Oh my gosh. Okay, so A and B. So you guys see A and B, they're down here in the lower right-hand corner. Observers starting from A can never arrive at B, but must arrive in 12 hours at a point somewhere between 3/4 of a million miles beyond it. Number 2, the observer loses his original baseline, which was the diameter of the Earth, and does not know the length of his new one, A, G, because the distance of the sun and the dimensions of the orbit had never previously been measured. So the observer loses his original baseline, which was the diameter of the Earth, and does not know the length of his new one, which is A to G. So the Earth is A to B. The new one is supposed to be A to G, which is supposed to be 3/4 of a million miles. So, because of the distance of the sun and the dimensions of the orbit have never previously been measured, he can't know what the distance is from A to G. The angle of U from G, which is over here, is entirely different from the angle of U from G is entirely different from the one intended from B. Mars itself has moved along its orbit during the 12 hours to a new position, which is very uncertain. So Mars is going to be M, is up here close to grid line E. We're looking at the little thing. Mars itself has moved along its orbit during the 12 hours to a new position, which is very uncertain. And then number 5, the triangulation which was intended is utterly lost, and the combined movements of the Earth and Mars plus the 2 lines of sight make up a quadrilateral figure, which of course contains angles of 360 degrees and by means of which no measurement whatever is possible. In conclusion, Dr. Hanley was mistaken when he supposed that 2 observations made from a single station with an interval of 12 hours between them were equivalent to 2 observations taken simultaneously by A and B. The actual attempt to measure the distance to Mars by the use of the Dural method will be dealt with in the proper order of events. But for the present, what more need I say concerning such ingenious expedients? I think that's his way of saying, how much more do I need to say this is a dumb idea? Anybody else agree? What more need I say concerning such ingenious expedients? A curious example of theorizing to no useful purpose is the theory of the abrasion of light, which is regarded by some as one of the pillars of astronomy. Oh, we're about to get into a good one. It aims to show that if the velocity of the Earth were known, the velocity of light could be found, while at the same time it implies the reverse, that if the velocity of light were known, we could find at what speed the Earth is traveling around the sun. If Bradley intended to prove anything by this theory, it was that the apparent movement of the stars proves that the Earth is in motion, which surely is begging the question. The fact that the theory of the abrasion of light has no scientific value whatsoever is very well shown by the following quotation from its author. If the observer be stationary at B, we got another diagram. Hold on. Hold up. Wait a minute. Got another diagram with it. Another diagram with it. Another diagram number 7. We gotta make it bigger. We gotta make it full screen. So, if the observer be stationary at B, see diagram 7, the star will appear to be in the direction BS. If, however, I know, I'm BS. Okay. If the observer be stationary at B, the star will appear to be in the direction BS. If, however, he traverses the line BA in the same time as light passes from the star to his eye, the star will appear in the direction AS. So he's saying we're standing at B, and the star appears to be where the star is at S. But if he walks from B to A, and at the same time that it takes for the light to pass through his eye, it will appear in the direction of AS. Am I understanding that correctly? That doesn't make any sense. If the observer be stationary at B, the star will appear to be in the direction of BS. If he traverses a line AB in the same time as light passes from the star to his eye, the star will appear in the direction AS. Okay, so I guess you're saying the star wouldn't move. Well, no. I don't know what's tripping me up here about that, but that's tripping me up. Because in my head, I'm like, if I'm standing at B and I walk and the star is SB, and I walk from B to A, then the star is AS because I'm over at A. Okay, that is true, but it would be no less true if the star itself had moved to the right while the observer remained at B. But why did he say if he moves from B to A in the same time as it takes light to pass from the star to his eye? Thank you. Okay, thank you. I'm glad I wasn't the only one that was tripped up by this. Okay, because he was like, what you talking about? What are you talking about? If he moves from B to A in the same time as it takes light to pass from the star to his eye. Why did he say that? It is a needless qualification, for if the observer moves to A, he will see the star at the same angle while he walks there at 3 miles an hour or goes there by airplane at 1 mile a minute. It has nothing to do with the speed of light, and the velocity of light has nothing to do with the direction of the star. It is merely posing and using words for no purpose. Look at that. He took the words right out of my mouth. And what an amazing way to close out chapter 4, right? Like, there was no reason whatsoever to just make up light, right? Like, come on. Because if I go over there, then that means it's over there. Like, why are you just trying to come up with hard stuff to make me like, well, you gotta be smart, and you gotta, it's gotta be the light, the reflection of the light to my eyeball, and I can't just because I walked over there. Oh man. Well, You know, guys, I appreciate the way that he writes. I enjoy relearning how to read out loud, because it's not that I don't know how to read, but my brain, I guess, tries to fill in the blanks faster. You know, there's a shortage between my brain and my mouth, that's for sure. So I appreciate you guys bearing with me and chilling out with me as I look up the words. They're great. I love the language. It's just, he is brutal and he's honest, and he's like, so why are you saying this? It is merely posing, using words to no purpose. I mean, I couldn't say it better myself. So that was chapters 3 and 4. Everyone, we are making it through here. We are making it through. There are not very many chapters. As you guys know, this is a tiny book, okay? And we're almost halfway through it. We're almost halfway through it, so it won't take us long. I'm wondering if we should just pick this up more, to get through it faster, because there's so many books that I want to get through. If I should, try to do more than one stream a week, but I don't know if I don't know, because there are so many channels or so many people doing things. I mean, like I said, I need to do this for myself anyway, so it shouldn't matter. If I want to read this book faster and I'm going to do it on live, I should just do it whenever I want to, right? Do whatever. And you guys are more than welcome to come and check out and catch up, whenever you have time. But the next chapter is called The Distance to the Moon, chapter 5. That's going to be interesting. Chapters 5 and 6, romantic theories. So I've got plans to be here next Tuesday night at 9:30. So I hope you guys come. If I ever do decide to pick it up or to go faster, I'll let you know. But that's just something to kick around. So leave a comment. Let me know what you think. If you think this once a week is cool, or if you think more than to go through the book faster, you want me to read longer. I mean, I feel like an hour is a long time, and I don't really want to be the one to put out long videos. I feel like I want most of my videos to be shorter, but of course, when I have guests on, it's going to be longer, and then reading is going to be longer, so we need to keep it down. We don't need to be too long, and I'm already rambling as it is, so it's going to be longer, and I pause when I read anyway, so it's going to be longer. And oh gosh, it is a good book, right? Isn't it, Andrew? It is a good book. So I'm enjoying it, and I look forward to learning more about it. Thanks, Pepper. Appreciate you being here. Pepper, don't forget. Don't forget. No, you messaged me. I emailed you, Pepper. That's right. I need to update the flyer. Okay, so shameless plug. Starting January 9th. Let me get this book off really quick. Starting January 9th, I will be interviewing the Truther ladies in the Truth community, where I'm going to be with the sisterhood of my woke warrior queens. We are coming together and we're sharing our ideas. My first guest is going to be Jennifer Waters Above is going to be here with me. I can't wait for that. So I'm going to be plugging that up here on my Facebook and other places. All the ladies are welcome to join me. Guys, I mean, you're welcome to show up, but we ain't going to be talking about nothing you want to talk about. Okay. You can come, to all. I got so much other stuff. You don't need to, right? It's all good. No, but y'all can come if you want to. But it's a place for women, so we just not talking to you. You just gonna be there. Y'all know how to be wallflowers, right? Y'all could be flies on the wall for a second, right? Let me stop. Okay, guys, I appreciate you for coming by. It is 10:45 Eastern Standard Time, and I am ready to get to bed. I'm working overtime this week. But Flatlantic, oh my gosh. I keep saying Flatlantic too. No, that's right. It's Flatlantic, because I keep saying Flatlanta. That's what it is. But I say it right when I'm talking to you guys. But then I second guess myself. I need to stop doing that. Anyway, Flatlantic. So how about I got my third flat tire in a month. Seriously, I already have an appointment for Thursday to go and get it checked, and the place is already an hour away, and I need to get some fix-it rubber goo something or other to get it in there. So I would appreciate my prayer warriors out there to put out good vibes to the creator, get to the source, to ask that I can just make it to Greenville, and then I can make it to Flatlantic, because I have been so excited for this, and it would completely make my year to be able to spend it with my like-minded brothers and sisters. So please pray that I'll be able to do that. But other than that, that was chapters 3 and 4 of King's Dethroned. Thanks for stopping by. Please give me a likes, give me a thumbs up, and leave a little comment about how much you liked it or didn't like it, or you wish that I would do more intervals, or you think that I should do less interjecting and just read. I don't mind. Tell me what you think. How it should go. I want to know. I want to know. So let me pop over here to YouTube real quick and see. Oh, I forgot. Oh, no, I didn't. Pepper's already good. There we go. We got some wrenches to give out. All right. People have been wrenched up. And thank you so much to Andrew and Pepper who are still here, and L. Cole. I appreciate you. You guys are awesome. I love you so much. Thank you so much for all your support and encouragement from the community. It has been awesome. Thank you for being here. And we will go ahead and we'll close this out. Wait, why can't I hear it?
Butterfly in the
Oh, Lord. What is happening?
sky. I can go twice as
Maybe I need to remove and start again. Yeah, I'll give me a second. I'm learning. I don't know why it will never show me all of my files. Oh, man. The sound's really not playing.
butterfly
It was
in
playing
the
last
sky. I can go twice as high. Take a look. It's in a
Oh,
book.
can you hear
A
it?
reading
Can you hear it?
rainbow.
Okay.
I can go anywhere.
Bye, y'all.
Friends to know and ways to grow. A reading rainbow. I can be anything. Take a look, it's in a book. A reading rainbow. A reading rainbow.
Ari's reading rainbow. Bye, guys.